So, quick introduction, I'm Paul Collins. I'm a Senior Program Manager with the Office 365 engineering team, looking after networking, network performance for the service.
And Jeff Mieleff, Principal Program Manager with the same team, working on the same stuff.
Just a quick show of hands, who was at the other networking session we had for Office 365 on Tuesday? Just a few of you. You may see some overlap at that session. That was more about the strategy, and we try and weave in here the actual implementation and the why around what we do with Office 365 networking. So, to get started, I'll talk about what the problem is we're trying to solve with enterprise networking. This diagram will probably look pretty familiar to a lot of you. That's kind of simplified view of an enterprise network infrastructure where the dotted line represents our walled garden, our corpnet, where our crown jewels sit. Our servers, our applications, our data sit in there. And to get in and out of that network, we require a security stack. We go through out to the big bad internet, and we look at that traffic very closely. But our branch offices use an MPLS circuit to backhaul to the data services application in the head office, and also to egress out to the internet. And we also force our roaming users to do the same through a VPN concentrator. Again, makes perfect sense with the old model in that all our services, everything we need is within that environment, and we can also protect those users' internet access by putting them through our security stack. But that security stack probably looks a little more like that. We've got a lot of expensive equipment doing various things, proxy servers, maybe WAN accelerators, secure web gateways, DLP, SSL inspection happening here. And this is all expected because what's outside is unknown and untrusted. But this model doesn't fit with the cloud world, and it causes us particular problems with Office 365, which we'll go through today, show you what the problems are individually, and how we solve those problems with a modern network. So let's start with Exchange Online. One of the problems we see, if you think about that remote site that you just saw, latency to the egress can be high. Previously, this isn't a problem because the Exchange server we're talking to sits in the head office, so we've not got to go through that security stack and then out through the internet to the service. SSL break and inspect, when we have to go through that security stack, that costs us latency as well while that function is performed. And Exchange or Outlook is pretty strong in handling latency on itself when it's running in cache mode. But non-cached operations with high latency will be slow. So search, FreeBusy, opening calendars. Whenever you do this over a high latency network, you'll feel that latency. One of the main problems we see, though, with Exchange is the way it connects. If you think about what that proxy, that on-premises proxy was designed to do, designed to connect you to external resources where you go and get the data and then close the session, like a transient session. So those resources get reused very quickly. With SaaS services like Office 365, we connect to that service and we keep those connections open all day. So you can see on the graph there, that's my machine over the course of 24 hours, where I'm monitoring the number of TCP connections it's using. And you can see the average is 5. Now you multiply that up by the number of users, that's an enormous load on that proxy, especially if it's doing things like SSL inspection on all of those. So, all this combined means a very large increase on the load on that proxy. And yes, we can throw money at those proxies and add more of them, but we don't solve the latency problem. And then I always ask the question, well, what happens with the next service you need to roll out that causes this problem? Do we throw some more money at it? There's a better option. So Skype for Business and Teams has a different set of problems with this infrastructure. Again, we've got the same issue with latency, connecting out to the relay server. The main problem we see is that for media traffic, Skype and Teams prefers to use UDP over TCP because it's a better protocol for the behavior, the functions that it's doing. With UDP is much easier for us to handle out-of-order packets, drop packets, etc. Whereas with TCP, we have to deliver every packet, and the other problem is, through a proxy, it's going to introduce things like jitter, where when we're talking, you want the packets arriving in the order that they were sent out, so you can clearly hear what was said. Jitter means those packets are bunched up or spaced out, and then that It's when you start sounding like a Dalek, when we can't fill in the gaps. And think about, again, that proxy. You've got all the clients connecting through there for their connectivity to the signaling server, but then what happens with an all-hands call when everybody's on a call through this proxy? Again, a problem for the service. And just to show you how easy it is to run into problems with this scenario, this is a test I did at home using our Skype for Business network assessment tool. So on the left-hand side is me running it using my Wi-Fi, so not even an Ethernet connection. And it passed everything, low latency, low jitter, no packet reorder or packet loss. So I'd have a high-quality call or meeting. And then I set up a proxy in Azure. Still not far away, you can see 35 milliseconds away. So we're not replicating the latency problem I just described. And this proxy is doing nothing. It's not running any users, it's not getting anything other than this. And we failed the jitter test through one use of that proxy that is very well set up, very well spec'd. So you imagine what the impact of a proxy array that's very busy with users going to YouTube and whatever else they're going to. Significant. And then we look at SharePoint, stroke OneDrive. Same problem with latency again. But then we've got the load of the data coming back and forth through the proxy that entails. So, you know, all the data that used to go to the SMB file share at the head office is now going out through the proxy, and we're SSL inspecting and looking at it as it goes through. The end result, poor performance, slow file transfers from OneDrive or SharePoint. The other problem is scalability, that SharePoint and OneDrive use the same Anycast address for all connections. So if you're using something like port over subscription to do the NAT, works beautifully when you're talking to different IP addresses at the other end. We can reuse the same source IP and socket pair. But when you've got the same IP address at the destination, null and void, you can't do it. So we've got multiple problems with this model in terms of scalability, latency, cost, etc. So we now know what the problem is, and let's have a look. We did a little demo to show you what the impact of that is on the individual services. So here's a representative example of a customer, Contoso of course, 80,000 users. We're using all those workloads I just described, and we've got hundreds of branch offices connecting through to the USA to egress the internet. Relatively standard model we see, and that egress has state-of-the-art proxies, DLP, SSL break, etc. So this is the Sydney office connecting to Office 365 through our head office in USA. So here's my user in Outlook. So what we're going to do is a couple of tests just to look at what the performance is. So first up, I'm going to do a PS ping test to the front door of the service, and Jeff will talk a bit later on about what we mean by the front door. But we're going to connect to outlook.office365.com, so this is what Outlook uses to connect to Exchange, and you can see there, we've got around 250 milliseconds of latency. So pretty high, but we can handle that in most cases. But now let's have a look at search. You can already see it's a bit clunky. You won't be able to see, but there's a timing on there that we can pull out, the search time, which is around 320 to 450 milliseconds for the search to complete. So let's have a look at archive and calendar experience. Now, you may well really feel what this is. You may have seen it before. We're clicking on an email, and now it comes up. Click on another one. There it is. No, not there. There it is. So not a good user experience. And the same goes for opening a calendar. Remember, all this stuff has to be done online. It's not cached. So this is a result of the network here in this case. So let's open this user's calendar. Nothing. Furiously start clicking on it. Still nothing. And I think you'll probably agree, if your users phone up to complain about this, they'll say your experience is dreadful or something to that effect, maybe slightly worse. And the other problem we see with this, because we're still trying to get this calendar invite, the Outlook client's hung while it's pulling that data in. It's not a beautiful user experience that we expect. So moving on to SharePoint. So we want to open a PowerPoint file from SharePoint. Let's click on it and download it. And we're connected by a wet piece of string by the look of it. So that's going to take 5-6 minutes, so I'll give up and send a carrier pigeon for it. So about 5 minutes to download that file if we left it. And finally, we'll run that Skype for Business network assessment tool we showed you before. So this is going to check all those core quality metrics, the latency, the jitter, etc. And rather than wait 17 seconds, I'll show you what the results are while it's running. Basically, all these will fail. So the Skype team have outlined metrics that say you need to hit these markers in terms of latency and jitter to have a high quality call. This is not achieving that, so our users are going to have a poor experience with Skype. Sound familiar? The behavior will feel familiar in some cases if you've had these problems. So, how do we resolve this problem? Well, we came up with a set of principles to help guide you from a high level, and we'll dig into what these mean. Firstly, differentiate traffic. Understand the differences between the endpoints required for the service and deal with them differently. These two I'll talk to as one. Egress your connections as close to the users as possible. So once we've identified that important traffic, egress them as close to the user as possible, optimize the route length onto Microsoft's backbone, and avoid hairpins like our VPN connectivity was a hairpin. And finally, with that list of differentiated traffic, assess network security. Look at where we're duplicating what you're doing at the network edge in the application layer where it doesn't cause a bottleneck. So let's dig in, starting with the differentiate traffic section. So before we dig into that, about a year ago, we had quite a large number of IPs for the service. You can see around 1,000. A lot of /32s, which is then a problem for maintaining allow lists, etc. So what we did, we went about and tried to consolidate IP space into wider ranges, and we've pretty much got there. We've reduced that down to about hundreds of IPs in that space. Skype, for example, last time I looked, when it was before we did this, I think there was somewhere around 600 or 700 IPs required for the service. If you look today, well, I looked last month and it was 29, and hopefully it's a bit lower than that now. We use much wider ranges, which means the change rate should be much lower as well. Thank you. Somebody was hit by that problem. So the other thing we've done to try and help you focus on the traffic which really matters, take that first principle and apply it, is look at the URLs and decide how to treat them differentially. And we've had a look at them and decided which ones really warrant that advice, which ones are really going to impact your standard infrastructure. So optimize is our core list. These are the ones you really need to take care of. These are the ones that caused that problem that you saw on the demo slide. And it turns out there's literally 2 Exchange endpoints, URLs, 2 SharePoint / OneDrive endpoints with a small number of IPs, and the IP addresses for Skype Media. If you optimize these, that's somewhere in the region of 70 up to 90% of the volume of traffic in terms of bandwidth, transaction count, and connection count from that very small list. So you can now focus on that very small list, optimize them, and deal with the allow and default buckets separately, which hopefully makes that process much easier. So the optimized list, as I say, is the high volume, highest impact on performance, most sensitive traffic. So we expect a low rate of change in this space in terms of the IPs and URLs. We have a set of criteria an endpoint needs to meet before we put it in here. We strongly recommend bypassing proxies, send this traffic direct. And because you've got a small list, it's much easier to assess the security elements in the service against these endpoints. For the allow list, you still need these. These are still required to be accessible, but they're not high volume, not necessarily latency sensitive. So we don't have to focus on these initially. We'd ideally like to send these out locally, not SSL break them, but they're less important than that first bucket. And then finally, you've got the the default range, which is your YouTube endpoints for help, and the other bits that your security team would really worry about breaking not SSL decrypting. And they can go via your standard internet egress without any problem. So hopefully that makes it much easier to focus on the traffic that matters. Now, to deliver this, we're just about to replace the XML file where we publish this data with a REST API-based service. It's live now. You can see it and use it. The data's live. But October 2nd, we're removing the XML file, and you'll have this service in place. So the REST API has that data. It has the markings in the data for those categories. So as a customer, you can write a script, a PowerShell script, to pull the data in whatever format you want. It's a JSON file. And deal with it to build your allow lists or your pack files or so on. And from an equipment perspective, we're working with a number of vendors to allow you, or allow those devices to call into this REST API and pull the data in automatically to prevent you from having to do it in the first place. A little more on that later on. So, if you can focus on those core endpoints first, you'll be able to deliver a high impact, a high improvement rate for your users with hopefully relatively little effort. So just a bit more detail on what those endpoints are. So for Skype, they are the media ports, the UDP ports for Skype media, and the IP addresses. There's no URL for this because we found out the relays during the connectivity phase for the client. So they're just the video, audio, etc. And the reason is, like I explained before, we can then allow UDP traffic to go direct, which is particularly sensitive to latency. For Exchange, we have two URLs, one that's used by Outlook clients and one by Outlook Web Access. This is the high volume problem I talked about before. Again, latency is still an issue, multiple TCP connections, so we can focus on bypassing the problem infrastructure with these core endpoints. And then for SharePoint, you can explicitly say mytenant.sharepoint.com, whatever your tenant name is, contoso.sharepoint.com, and send that direct. So again, that high volume traffic, when we saw downloading the PowerPoint file before, we can bypass all that infrastructure and pull it in directly. And as I said, that new REST API-based service is there. We have various elements. We have the endpoints, which has the data you need, the version number, which you can query to see when it changes and then automatically pull in the change, and a list of what the changes are when we add them. When we add an IP range, we'll list in that file what's happened. So that's how we differentiate traffic, and hopefully that's positive news. We can much easier focus on differentiating the traffic that matters. So let's have a look at the middle two. So why does Microsoft want that traffic out locally? Well, it's because we can do multiple things with it. The blue lines here show Microsoft's global network. We have presence, the blue dots there, are peering locations where we can peer with your ISP to get the traffic onto Microsoft's backbone. If you egress locally, in the vast majority of cases, you'll be on Microsoft's network very quickly. You can see the stat there, within 63% of the global GDP within 25 milliseconds. If you egress here in Orlando, you'll be on Microsoft's network in Miami. If you do it in New York, you'll be on Microsoft's network in New York. If you do it in London, London, and so on. So we want your traffic on this network as quickly as possible because we can do multiple things with it. Obviously, it's optimized to get your traffic to where it needs to go as quickly as possible. And your data is held in these orange dot locations. So you may be connecting from a country where your tenant isn't located. That network is used to connect you back to wherever your data is. And as I say, we're constantly adding new geos. So we drive that local breakout model because it works for everything. If you think about, we've got the yellow triangle there in Dubai. We're opening up a data center there soon, which means that network connectivity locally, if you egress locally, when that peering comes up in Dubai, then you don't have to make any architecture changes to take on that benefit. So a quick list of where those locations are, where we have peering. You can look them up yourself on that aka.ms URL. 8075 is our ASN number, and it will show you exactly where Microsoft's nodes are across the world in terms of our network peering points. And If we think about networking for cloud, I said before it was a shift from what we used to do. We used to build a network to connect our users to where our data was. If you think about distributed SaaS services like Office 365, it doesn't work like that anymore. The data is not in a place, it's in a region. And Microsoft has infrastructure in different regions. Even though your data may not be there, your client can connect to the front end of the service locally. So we have those network POPs I described, service front doors, which Jeff will talk through a little later, and your data. So we have 45 plus data centers and growing, but we currently have 100 plus service front door locations closer to your users than the data centers. And we have 190 plus peering locations to 2,700 plus networks, even closer to your users. And over time, you can expect those things to come closer and closer to your users. And the better and better the performance will be if you have local egress. So let's just have a quick look at an example of what happens if we do this, follow this model. So here's my user is going from San Francisco over here to Orlando to egress to the internet. The ISP here pairs with Microsoft's network in Miami. We hit a local service front door, which connects to the data. So this is 65 milliseconds to hit the front door of the service. Service will work over this latency, but there are better options. We have local peering available in San Jose. So if we locally break out, we can connect to a service front door in Seattle, in this case, in 25 milliseconds. So we shaved off 40 milliseconds instantly with a local breakout. But as I say, we're constantly expanding this front door service to the edge of the network, and we actually do have front doors in San Jose. So that latency comes down to 5 milliseconds. Now, this is the difference between on-premises look and feel, and this feels sluggish like you saw before. We can also do macro improvements. We can figure out from a Microsoft side that this user keeps connecting to their mailbox from the West Coast. So let's shift their mailbox locations over towards the West Coast if we can, further improving the service performance. And finally, this is really what the original problem is. Let's say we egress through our head office in DC, or we decide we're going to put an express route circuit in Washington, DC. Now we have latency of 85 milliseconds to the service, which is a significant difference from that 5 milliseconds if we egress locally. I also mentioned there the DNS resolution needs to go with the egress as well, and Jeff will talk about why that's important a little later. Finally, let's look at security. We've isolated those optimized endpoints. Now we need to have the discussion with our security team. Are you happy to not SSL break this traffic as it leaves our network or comes in? So I've changed that last column there to describe what we've got within the service to secure those elements. So take the Exchange Online example there. You know, we look at that endpoint and say, well, we've got Exchange Online protection, which is doing its thing. We've got anti-malware protection in there. We can enforce DLP within that connection in the application. And these are often replicating what you're doing at the network edge, which causes a bottleneck. So with these defined small list of endpoints, it's much easier to assess the risk of bypassing SSL inspection on this traffic. And hopefully, that means your security team will sign off on that, and you can egress locally and gain the benefits of doing so. So how do we implement this? What does an implementation look like? Well, I've sat down and drawn a few examples I've seen customers implement in this model. So this, just a kind of scene setting slide. This is the original connectivity for Contoso here. Branch office uses a router to connect across the MPLS to the head office. So every piece of traffic uses the MPLS. And then we egress through that standard egress that I talked about, the firewalls, the DLP, etc. So that MPLS circuit is probably very expensive, and we're funneling a lot of data down there, especially with Office 365 and updates. Solution, we can put SD-WAN devices in that branch office. And you can see there we've connected 2 different ISPs into that SD-WAN device. Now, those local internet connections are going to be much, much cheaper than your MPLS circuit. And we can look at the cost savings. I've got a slide in a few seconds to show you cost savings there. But By using those local breakouts for the traffic that you trust to go out direct, we can reduce the size of that MPLS down, saving money. If we lose an ISP here, doesn't matter, we'll just use the other one. The SD-WAN devices are generally clever enough to figure out we'll continue to use this one that's working. And you'll notice I put Windows updates in there. There's a shift in the way that updates are applied within the enterprise. Rather than the 6-monthly, yearly, 2-yearly rollout of patches, updates, they're coming thick and fast now with cloud services. We update software monthly in some cases. So that data is held on CDNs, very close to where your users are. So we can use this infrastructure for other things other than Office, for updates, for example. So we don't have all that bandwidth utilizing our MPLS. And I've put other cloud services there. Azure, for example, you could connect to Azure through this, or any other trusted cloud service that you deem necessary. And I always like to talk to customers about this. This isn't an Office 365 thing. Office 365 is often the first thing that pushes the door here and says this needs to change. But there will be masses of other things that come behind it when you've got the right infrastructure in place. And you can also use this SD-WAN to connect back to your head office if you so wish. You can tunnel through the devices back to an SD-WAN device at the head office and do away with the MPLS at some point. And I've seen many customers do this. So they're now no more MPLS, they're using SD-WAN globally to connect anything they need. Another example where we don't want to put local breakouts, we don't want to manage internet circuits at every one of our branch sites. So we keep our MPLS circuits that come back to a regional office, which is, I don't know, 20 milliseconds, 30 milliseconds away from the branch office, and we put our SD-WAN device in there so we consolidate that connectivity and simplify our connectivity for our users. And again, with this model, we can do away with that MPLS in time when we're happy that the new solution is in place. Another example which I'm seeing is relatively popular is using the same feature, the SD-WAN device, multiple internet circuits, but all traffic is funneled through a cloud-based secure web gateway, a cloud proxy, if you will, but they're generally more than that. These devices sit on the internet, hopefully close to your users, so we're not introducing latency. It's really something I'd encourage you to assess if you're looking at this model. How close are these proxies that the vendor has, or the secure web gateway is, to my users? Assess that, assess how closely they adhere to our principles that we're talking about in terms of peering to Microsoft's network, how they treat that core traffic. Can you differentiate it on their devices? And you make an assessment. In an ideal world, from a Microsoft perspective, we still say that optimized list go out locally, but many customers do this just for simplicity. They fire everything through the cloud proxy service, and then you've got central point of control, visibility, etc. And we still keep our legacy egress for whatever it is within the head office that still needs to use that. And this model's quite useful for home users' PCs. They can still use these cloud proxies users sites wherever they are and send our traffic through into the same cloud secure web gateway that the branch offices do. So general benefits of local egress. Technical benefits, as I say, if you think about the shift of your data and services and application, they no longer sit in that walled garden, increasingly so. So it doesn't make sense to now backhaul traffic to a central location to come out. It doesn't fit with the new modern world. And I really find customers who implement that local breakout model become much, much more agile as a business. The network becomes a facilitator for the business to adapt to change, to deal with mergers and acquisitions, because the network team can say, when the CEO says, I need this rolling out next month, they can say, fine. Just tell us when, we'll turn it on. Rather than saying, I'm going to need $1 million for some more proxies. So there are a lot of advantages to this from a technical standpoint, no more so than Office 365. We can really improve our users' performance, our users' experience with the service by implementing this model. And cost benefits. As I mentioned, MPLS is often much higher cost than local internet connectivity. I am seeing MPLS costs come down because of this model. But a customer of ours, Kelly Services, agreed to allow me to use this quote about their network transformation. They have 10,000 employees spread across 900 global branches, and they realized a 60% reduction in their telecom OpEx costs by moving direct to the internet. That is significant, you know, and what they've done by doing that has allowed them to deliver 10 times the bandwidth at those remote sites for 25% the cost of their legacy connectivity approach. So they've improved the connectivity, they've improved the speed, the user experience at a much lower cost. And that's a trend I'm seeing with many customers who are starting to roll this out. It may not be initially cheaper as we've got, you know, still got the MPLS contract in place, but over time, you can, as I say, you can start to reduce the MPLS size or get rid of it when you're happy. So significant benefits of this model. So let's have a look at what the actual physical input of this is. What happens if we implement this model? So we've got that demo again, and I'm pinging this time it's the SharePoint front door, but it's still 200 milliseconds. So what we're going to do is run a PowerShell script to pull in those optimized URLs and IPs and apply them to our SD-WAN device to allow this traffic to go out locally rather than funneled through our head office. So we're just going to run that. It's going to configure the network device for us and just watch that latency when that goes in. Come on, there we go. 12 milliseconds, absolutely real. So this is talking to the SharePoint front door in 12 milliseconds, now it's going out locally. And you can see we're still going to a website here, yahoo.com, when we knew we wouldn't be busy. And you've still got that high latency, because we're going to the original infrastructure at head office to SSL break and inspect that traffic. Let's look at that PowerPoint download now. I can cancel my carrier pigeon. That is usable performance. Your user's going to be happy with that. They're not going to be calling up your help desk saying this doesn't work. Okay, now we're going to rerun that network assessment tool. And while that's running, we'll go back into Outlook and look what the behavior is like there. And literally all we've changed here is sending that core list of traffic out locally rather than send it through to our head office. So search, you can see there, it's come down to 130 odd milliseconds. So a much better, snappier user experience. And watch this one. Usable. Instant opening of that calendar item. So we can call it delightful. I'll let you choose which word you want to use there. But significantly better user experience for our users. And look at our Skype results there. All past that mark, which means our core quality, our meeting quality is going to be much, much better. So you can actually see there, that demo I think is a great example of how following those principles can really impact your user performance on the service. And with that, Jeff's going to talk to you in a bit more detail about how the services connect and utilize that global infrastructure to deliver that performance.
Thanks, Paul. Yeah, so Paul just spent the first part of the presentation giving a great overview of our guidance around what we would love our customers to build in terms of network infrastructure to take advantage of investments that we make on our side to try and provide the best possible end user experience. And I'm going to walk through fairly quickly what we do for the three major workloads, Skype for Business Online / Teams. It's effectively the same for the purposes of today's conversation, SharePoint and Exchange. And then we'll talk about a couple of additional related topics after. So in terms of Skype for Business and Teams as well, when we think about the way in which media traffic is managed for those products, essentially we're dealing with two different types of traffic. SIP traffic, so the signaling traffic that's used to initiate these media sessions, and the media traffic itself. So the voice, video, screen sharing, whatever it is that you're performing in the client. The signaling traffic is always going to connect to a pool of resources that are actually in the location of the tenant. So if you've established your Office 365 tenant based on the billing address that you put in the portal when you first created that tenant, if you've established it in North America, then this is always going to be connecting to capacity in North America, regardless of where you are in the world. That sort of initiation process is going to inform the client of the relay or the endpoint that it's going to use for media services, in that initial session establishment process. So for media traffic, the client will actually try a few different things. The goal here for the client is to be able to get some sort of traffic through, but it has no idea what's standing in its way. So it's going to try the optimal choice, which is UDP direct connectivity. UDP is far better at transmitting this type of data in a performant way. And so it will go out and attempt to make UDP direct connectivity to that endpoint that it's being directed to. It will also, at the same time, try TCP direct over port 443. Right? It's a pretty good bet that most corporate infrastructure these days allows TCP 443 out in some form. And so that's a decent choice for a second option. And then the very last option, we'll try using TCP via the proxy pack that's been pushed out to the device. We obviously prefer not to go through a proxy, so that's why that's the least preferred option there. But we'll try all three. We pick the one that works for us, basically. The one that in that ordered list is first able to get connectivity out. Important to understand that when you're having a one-to-one conversation, or sorry, a one-to-one media session, essentially within these tools, if you're on the same network, so you're on the same corporate network, you have connectivity without any sort of barriers in the way, that's a peer-to-peer conversation from a media perspective. So what we're talking about here in terms of performance improvements at the egress don't apply. This is all within your network. None of the conversation around local egress really applies to that particular conversation. However, if these two users are now on different networks that do have some barriers in between them, then we have a very different story. So this is labeled as legacy behavior. This is also, in many ways, the current behavior for Skype for Business. So in this example, we have two users in Europe, one user in Germany and one user off the coast of Spain enjoying a vacation, and they need to talk to each other. They're on different networks. Let's say they're at Starbucks or some other location where they can get some network connectivity. In order for them to have that conversation, we're actually going to use a media relay in the location where the tenant is. That's not going to be a terribly great experience. So we've done a bunch of work around a newer option, and this is the behavior that you'll see with Teams. It's also true that there are a subset of Skype for Business Online customers who've also been onboarded to this behavior as well. But think of this as the Teams behavior. Now what we're doing is, instead of actually going to the location where the tenant was created, this is a North America tenant, remember, to relay that media, we're going to a transport relay, and we're getting to that transport relay via anycast routing. So it's think of this as the same IP address that all this transport relay capacity is listing on around the world, and wherever your traffic egresses onto Microsoft's network, you will get connected to the closest transport relay to that physical location from a routing perspective, the most optimal path to that server. So in this case, we have a transport relay, looks like up in Amsterdam. And so now, even though this is a North America tenant, we're using a transport relay much closer to both of those users in order to manage that communication. You can get a much better end user experience as a result. So let's move on to SharePoint and OneDrive for Business. This is another great example. You're going to see some similarities to what I just described with the Teams behavior here. So SharePoint has gone from a model where they basically required you to connect directly to the location where your data was being stored and processed. So again, if your tenant was created in Europe, perhaps that's Amsterdam, perhaps that's Dublin, that's managing that active copy of your SharePoint farm or your OneDrive data. They used to require that you actually connect from client to that location with no assistance in the middle, right? So they've moved to an anycast model that connects through, again, what we refer to as a service front door. That transport relay that I mentioned there previously also sort of falls into this service front door model, where we're pushing these out as close as possible to our users, presenting them as the endpoint that the client connects to. And then that allows us to optimize the connectivity on our side via some cool tricks to ensure that we can provide a great end user experience regardless of where the user is and regardless of where their data actually is. So very optimized connectivity between these front doors and the location where we're serving the actual SharePoint data. So visually, what does this look like? We have a client that wants to use a SharePoint team site as an example. And that user is somewhere in EMEA. Their tenant is in North America. So the first thing they're going to do when they try and connect to tenantname.sharepoint.com, they're going to go to DNS. What are they going to get back? Well, I actually should say Anycast. Thought we corrected that, but missed it.
I fixed that, but no. I'll blame
So
PowerPoint.
anyway, they're going to get back an Anycast IP address for SharePoint and OneDrive for Business. If you go today and ping your company's SharePoint tenant FQDN, so contoso.sharepoint.com, and you look at the IP address you get back, and then you go do the same thing for microsoft.sharepoint.com, you'll find the same address, right? It's the same IP address that we're using for all of these SharePoint namespaces. So from there, the client will go and make that TCP 443 connection to that Anycast IP address. And using Anycast routing, we will find the least costly path to get you to one of these service front doors that's responsible for managing this traffic. And that effectively is, in many ways acting as a reverse proxy, but a very optimized reverse proxy for that traffic. When we actually look at the benefits associated with this, what we see is that we go from having a very, very painful, almost unusable experience for certain types of traffic where you're, in many cases, crossing an ocean, so the Australia to North America sort of scenario, to something that actually becomes usable. And in many cases, delightful, to use the term that was in one of the slides earlier, again, regardless of where the user is and regardless of where their data actually is. So I'm not going to walk through all these numbers. They're in nice big bold letters. You can see what some of these improvements look like, and it's quite amazing the benefit you can get by adhering to the local breakout model. So Exchange, near and dear to my heart. We left the best for last. So Exchange has changed their model a bit as well in terms of connectivity, and the change here is really around moving from a system that was based on GeoDNS, so locating where we believe your user to be physically located based on the source IP of the DNS requests coming into us during that connection establishment phase, to moving to an Anycast model again, where we are much better able to identify where the traffic for that user is egressing onto our network and get them to a service front door for Exchange as quickly as possible. And those service front doors in Exchange are known as CAFE, Client Access Front End. So the way this works for Exchange, and again, this is the normal behavior. The GeoDNS behavior actually does still exist as a backup, and we may occasionally use that. So it is important for you to understand that GeoDNS is still out there. I'm not going to tell you that it's completely gone and we're only using this model. It is very important for you to make sure that you are resolving DNS as close as possible to where your traffic egresses. So don't use a DNS provider that's halfway around the world from where your traffic egresses, because if we are using GeoDNS, we may make a very bad decision from a performance perspective about how to try and route your traffic on our network. But in the Anycast scenario, which is the vast majority of the cases now, the way this works is an Outlook client will go do a DNS lookup for outlook.office365.com, and we will actually send that client a CNAME. We'll go say, well, that's a CNAME for outlook.ms-acdc.office.com. This is not a reference to the band. ACDC refers to Anycast DNS on CAFE. And if you go look at the name server records that are responsible for resolving that query, you'll find some of Microsoft's Anycast IP addresses. So we now have DNS capacity, DNS service running on CAFE servers across our data centers. And because we can now know that the DNS requests that come into those specific units of capacity on Cafe are coming from a close physical location, we can now provide a response that's appropriate for that location. It's a much more reliable way to actually manage this traffic flow and ensure that users are getting to Cafe capacity that's as close as possible to the user. So we provide a few addresses of Cafe capacity, basically VIPs, load balance VIPs sitting in front of these racks. We provide multiples for high availability, right? So the client can fail between them if it needs to. And then the user is connected. Their proxy is, the client picks the first one on the list, opens HTTPS connection to Cafe, and that then gets proxied back to the mailbox server that's responsible for their active database. So I also want to touch briefly on inbound connectivity. This is not something we have spent a lot of time historically talking about within our guidance, but it keeps coming up over and over again. Because for some reason, people like hybrid. How many of you are Exchange hybrid customers? Yeah, this is why. So inbound connectivity can be a little bit challenging, and we have not historically had the most clear guidance around this. So I wanted to cover both the Exchange and SharePoint story and provide some clarity around this, and also a way to think about how to manage that inbound connectivity in a way that aligns with some of the guidance that we've been talking about so far today. So how to optimize that from a performance perspective. So for Exchange, the way that you publish endpoints today to the internet for this hybrid connectivity is effectively the way that you would have published Exchange for remote users. So if you're making Outlook Anywhere or Mappy over HTTP or Exchange ActiveSync available on the internet for your mobile workforce, we're going to use those same endpoints for hybrid connectivity in general. So I point on this slide to a blog post that one of my close colleagues, Greg Taylor, wrote a few years ago that describes kind of a new way of thinking about our guidance in this space, that maybe all you really need in order to make this happen is a load balancer sitting in front of your Exchange servers. It's certainly one option. You've got your external namespaces published in public DNS, because this is all public connectivity between O365 and your infrastructure. And we recommend generally following our principles of connectivity here. We want to make sure that you're not going to be backhauling this inbound traffic across your corporate WAN, right? That point on your network where you're publishing these endpoints ideally is going to be pretty darn close to the physical capacity within your network, where that capacity, where that mailbox data is that's going to need to be accessed. So if you're going to be migrating mailboxes, you don't want to have your MRS endpoint sitting halfway around the world from where your actual mailboxes are, right? That's the idea there. We also recommend, again, aligned with some of our principles of connectivity, minimizing the impact of security controls on that traffic. Figure out what the actual threats are that you're trying to mitigate, and mitigate them. But don't just deploy devices or additional hops in that process just for the sake of adding complexity. We see lots of cases that customers run into roadblocks because of this additional complexity that's added. You want to be as clean as possible with that connectivity flow. In terms of high availability, again, you provide high availability for this scenario in the same way that you would for client connectivity for your on-premises deployment, through the Exchange preferred architecture and namespace design principles, using bound or unbound namespaces, and then providing a way to resolve those externally to the client, or in this case, to Exchange Online. You can add additional controls. If you have a need to do that, then we start talking about things like reverse proxies. Important to call out that much of that hybrid traffic, there's a caveat, this is not true for all of it, but much of it can't actually be pre-authenticated because of the type of authentication that we're using with this traffic. It's not traditional credentials that have a representation in your on-premises AD. So that can require a little bit of a mind shift and a fairly in-depth conversation with some of your security teams. We've also published a blog article that goes into great detail about how this traffic is managed and how it is authenticated on our side, ideally providing you with that transparency so that you can, your security teams can trust us and trust that traffic flowing through. Absolutely have to call out some phenomenal work coming out of Jeff Kisner's team. in the Exchange organization. So hopefully you got a chance to go to the Exchange hybrid session that was delivered yesterday, where he talked about a new tool that we're calling the Exchange Hybrid Agent. And that actually makes everything that I just described kind of meaningless, kind of pointless. What the Exchange Hybrid Agent does, and this is in many ways modern Exchange Hybrid, is allow you to no longer have any internet-facing endpoints to manage this hybrid connectivity. So you don't have inbound connections coming from Office 365 into your deployment. It's using some of the technology that the Azure AD App Proxy team introduced some time back, where we basically have an agent that runs in your on-premises capacity that's responsible for managing the transmission of traffic that's originated in Azure. And so within Azure, we publish some lockdown endpoints that are really only usable from Office 365 associated with your tenant that allows that traffic to just flow through that kind of managed tunnel into your network. But from your perspective, this is all outbound connectivity. You don't have to look at this as inbound connectivity. So you let that flow out to Microsoft's network via local egress, along with your client connectivity, and it's now optimized. Very cool new technology. It's currently in private preview. I've got a link on there that you can go take a look at if you're interested in more information, and hopefully we'll have it in public preview and general availability very soon. In terms of SharePoint, I only have one slide on SharePoint. It's a fairly straightforward story. So the SharePoint team has very specific guidance in this space. You do need a reverse proxy to manage authentication for these inbound connections via certificate auth. And all of the conversation that I just went through about Exchange guidance in terms of trying to not backhaul this traffic across your WAN and properly locate these endpoints that Microsoft is going to connect to applies here as well. So if you're deploying hybrid search with SharePoint, you want to minimize that latency as much as possible, right? So the way to do that is to ensure that the path between Microsoft's network egress into your network and then from the edge of your network into this location where you've got your SharePoint capacity, you want to minimize that overall path length as much as possible. And the way to do that, local egress, make sure you're locating your endpoints where they need to be. One quick additional topic to bring up. Multi-Geo is extremely interesting to a lot of our customers. Anyone here considering Multi-Geo? Yeah, Paul and I have been staffing the networking booth down the show floor, and it's also the Multi-Geo booth, and we have become the Multi-Geo experts at Ignite this year. It's all everyone wants to talk about. So Multi-Geo, for those of you that aren't aware, is a new option in the service for currently for Exchange Online and OneDrive, and coming soon for SharePoint Online and Groups, that allows you to have a single tenant that's actually spread out across multiple regions. It's really about data residency. It's not about performance. I'll explain why that is in a moment. But the key thing to understand here is that it allows you to specify on a per user basis a preferred data location in any of these regions where we have Multi-Geo available today. And we will, on the back end, relocate the data for those users kind of in an asynchronous way, invisible to the user, in order to again, meet data residency requirements that are specific to subsets of your user population. That's what Multi-Geo is all about. So when we think about networking considerations for Multi-Geo, important to understand it's not a performance solution, and depending on your network infrastructure, Multi-Geo can actually cause performance degradation. All right? If you're not locally egressing, or at least regionally egressing, and backhauling your traffic to the region where maybe your data exists today before Multi-Geo, if you move users' data elsewhere in the world, it's fairly straightforward. You're going to see an impact there. Performance may increase. Nobody's going to stand up here and from Microsoft to make the argument that there's not the potential for some performance increase by moving a user's data closer to where they physically are. That would be rather ridiculous. So performance may absolutely increase here, but it's difficult to measure the real impact, because much of the performance of Office 365 today, of client connectivity into our service, comes from that service front door architecture, not necessarily where the data is located. So there may be some additional benefit beyond what we've already provided via the service front door architecture, but it's probably not going to be as significant as when we brought those service front doors online. So in this particular example, just to kind of drive this point home, let's say we have a customer whose data is stored in North America today. And so they have a corporate network spread out across Orlando, using a local example here, France and Japan. And they have a single egress. Get rid of the red line for a second. They have a single egress in Orlando, peering with Microsoft's network in Miami. So connectivity for that customer, regardless of where their users are on their network, will come to Microsoft in Miami. Now, their data is all in North America. So this is not optimal, but given that all their data is in North America, they may have decided, oh, we're gonna optimize our network based on our understanding of where the data is and how the service works, not following the guidance that Paul spent some time earlier talking about. And this is how we've ended up. So a user in France, backhaul their traffic to Orlando, and then peer with Microsoft in Miami and get to their data. Not optimal, but that's where we are at the moment. So let's say that this customer decides to buy Multi-Geo. All right, so they've gone and licensed Multi-Geo for some number of their users, and they now have regions lit up for their tenant in France and Japan. So they can take the data for that user that I was referring to in France earlier, and they can say, I want all the data for that user to be stored in France, in Microsoft's data center capacity there. Well, that's fine, except they've done nothing about their connectivity. So now in order to connect to that data store, I'm still sending my data to Orlando from France, peering with Microsoft in Miami, hitting a service front door somewhere close to Miami, and then crossing an ocean again. I crossed an ocean once to get over here to Orlando, and now I'm crossing an ocean again on Microsoft's network to get back to the location of my data. Not optimal at all. So what do? Well, we have to optimize our connectivity with local breakout. It's the same story again and again. All of our investments that we're making to try and provide better performance for our end users make an assumption that the architectural guidance, the direction that we're providing here around local breakout and getting your traffic to Microsoft's network as quickly as possible, we're making assumptions that you are doing that. And over time, you'll be able to accrue more and more benefit from that. But if you don't follow that guidance, then we continue to have a challenge. So with this particular example, user in France, egressing in France, getting on Microsoft's network in France, accessing their data in France. Much, much, much better as a result. So with that, I'll hand it back to Paul to talk about solving the bandwidth estimation problem, finally.
Thank you. I always think of Multi-Geo as a great example of where if you follow those network principles, it abstracts you from change in the cloud, change that is constant. You can consume that benefit instantly you want to if the network architecture is right to do so. So, as I've said, the biggest question I get from every customer, how much bandwidth do I need for Office 365? And it's not my favorite question because I don't have an answer for it generally. And I don't like not having answers to questions. The reason it's very difficult for us to answer is that the figure is variable per customer profile. So if we were to give you an average of what the data usage was across Office 365, what the same data usage of a 100,000 seat customer is wildly different from another 100,000 seat customer. And the same could go within the same segment, wildly different. So if you're making major infrastructure changes and planning and cost spending based on averages, it's not going to work for you. It's not a good option. So, if you use that average, you may lead to poor planning decisions. So the traditional approach to answer this question was we have calculators for various products. They're insanely complicated in some cases. And my problem with them is it looks at a small piece of the puzzle. You look at Exchange as a calculator. I mean, for a start, you've got to assume a profile of a user. Does that match what your user is? I don't know. If we put poor data in, we get poor data out. So we're back to square one, same problem again. And the service is constantly changing, the cloud's constantly changing, we're using different protocols, compression ratios, other things that mean that these are quickly out of date and not giving you accurate answers. And as a customer, you really want to see the whole bandwidth envelope from a user or for a user group. So this isn't a scalable long-term model for bandwidth estimation. What we've said in the past is monitor your pilot users and extrapolate that data out. Some customers can do that pretty easily. They just have proxy or equipment that spits that data out for them. But a lot don't. So we went away and had a look, how can I answer this question? So first time we're publicly talking about this, we've been building a beta solution to monitor network traffic using Azure Service Map and Azure Log Analytics. So how does it work? You have a user, so this can be any of your users sat in the office, at home, wherever. We install Log Analytics Workspace in Azure. And then on the client, we install two Microsoft components, the Microsoft Monitoring Agent and the Dependency Agent. So one collects the data, and one gets the data and pushes it into Azure Log Analytics. Very simple to install, low touch. And then that's just giving all the connection data from that client, not just Office, everything, into Log Analytics for the administrator to view. So when we've got that data in Log Analytics, we can then mine it. We can look at it. We can figure out what our users are doing in terms of network connectivity. So let me switch over. Rather than talk about this on a PowerPoint, I'll show you on here. That was my son when I was practicing this session to him. So this is Azure Log Analytics. So you can see here I've pushed this data in. I've already done some filtering just for time purposes here. But I've got a sample query. When we publish this, we'll give you example queries, so you don't have to figure out how to write these yourself. But essentially, what I want to do here is mine the data. For a certain time period, I had a call on Teams, and I want to see how much data was used during that call. And you can actually see what data we've collected in the table here. So we've got the username, the machine name, the process name, so that's what I'm filtering on here, source and destination address, ports, remote IP, and I've also got the source, the sent bytes and received bytes. So I can now figure out how much data this call has used. So there's multiple things I can do. Within Log Analytics, I've written a query here that's just going to build me a table to do this. We're going to look at the 95th percentile for this call, and it's showing me this particular call used 118 kilobits per second sent bytes, 31 received bytes. So I was obviously doing a lot of talking on this call. But we've instantly got an answer as to how much bandwidth this call has used. But we can roll this up to multiple users across the course of a day or across the course of a week and get an accurate figure for what our user profiles are doing in terms of bandwidth utilization. So one thing we can do as well is export the data that's collected to Power BI queries. So again, I'm not going to run that in terms of interested time, but I've got some sample dashboards here, and we will publish these sample dashboards. So all you need to do is load your data into them, and you'll get the same views. But here's Exchange Online. And because I can see the destination IP address, I can do geo mapping on that, and I can see 70% of my connections went to the United Kingdom, 25% to the USA, and a few others there where we were doing testing to other locations. And then I can see the usage profile in terms of bytes sent, bytes received, and then I can, if I want, have a little map show me where those geo mappings were found. This piece, so when we release this in beta, the UDP element we're still working on it, but it works, it's there. So this is a Skype for Business call for 34 minutes, and I can clearly see the amount of data sent and received during this call for that period of time. So again, this is just one user, but it's very, very easy to do this for multiple users at the same time across your suite of user profiles to get an accurate figure for what's right for your environment. Here's another one we've built for SharePoint. So the way you can filter this data, you just need a unique identifier. So you saw the first query I ran in analytics. I was querying on Teams, because that's the process I was interested in. Some products, it's not easy to do that. OneDrive is a good example, because I can be reading data from OneDrive from PowerPoint, from Outlook, from the Sync client. So what we've done here is write a filter that looks at the destination address. We publish the IP addresses for the SharePoint/OneDrive service, and that's what we're monitoring here. So you can now see how much data per process, and I can then total that, obviously, and that gives me an accurate figure for OneDrive. And again, I've got my data in, data out, etc. And finally, here's one for Teams. So this is where we were doing audio and screen sharing. So you can see the bytes sent. I was doing the screen sharing here, so the bytes sent is much higher than the bytes received. But again, a deadly accurate view of the data used during a call, which should help you to get the right figure to do your bandwidth planning. So that tool, we're hoping to have that ready and out for a beta, and we'd love your feedback, what's working for you, what features are missing, what dashboards you'd like to see. So we'll make sure there's a good feedback mechanism for that when we push it out. But it gives you some real insights into your data. I'm based in the UK, and Jeff's in Redmond. Can anyone guess what time of day Jeff gets online? So at 3 o'clock, you can see, or 4 o'clock in my day, you can see a sudden spike in data coming into my Outlook client as Redmond wakes up. But it wasn't really Jeff, he's never up at that time.
Thanks.
Okay. So that's our bandwidth tool. As I say, we should have that out in beta by the end of the year, and please do give us your feedback around that, or talk to us after if there's a particular thing you're struggling with in that space, and we can see if we can include it. One other thing, we announced this on Tuesday in the networking session, but I'll go over it again. We've announced a Microsoft Office 365 networking partner program, where we're working and collaborating with the networking industry to identify solutions that meet these principles, that help you to implement those principles in a simple, scalable, adaptable way. So we work with these vendors and make sure they adhere to our principles. And we're still working through the initial phase of this, but these are initial network clients that have been signed up to this. A lot of them are down on the expo floor, so if you're interested in the SD-WAN solutions, for example, I talked about earlier on, a lot of these vendors are down in the expo hall, and they'll happily have a chat with you about what their product does and how you could implement it into your environment. And to wrap up, takeaways. Hopefully, we got across that SaaS and cloud services is disrupting network and security. So you really need to re-envision how you connect and protect your enterprise to map with this new world. Expanding your network security boundary with the concept of a SaaS tenant. But as I say, we don't think of it just in terms of Office 365, in terms of cloud network connectivity. The user experience is paramount for success with cloud services. So if we get the same principles in place, you saw the impact on the user experience in the demo slide. And just to reiterate, don't forget DNS resolution. It can have a real impact on performance. SaaS will evolve, and Multi-Geo is a good example, as I said, where we're introducing new services that rely on this model to be in place to be effective. So those principles are out there just to help you, guide you in the right direction, and then hopefully we've got documentation out there that helps you drill in to deliver those principles in your environment. And please have a word with your networking and security team around this and see if it's on their roadmap, they're aware of these things. Often they are, but it's their decision that hold the key to success of an Office 365 rollout and, there's that word again, delightful Office 365 user experience. And with that, we have 5 minutes left for any questions. If you could use the mic because we're transmitting this out. And I'm sure you're sick of being asked to evaluate sessions, but it really is important to make sure that the quality level keeps increasing year on year. If you let us know which sessions you like, then the team really do use that feedback to build a better Ignite next year. So with that, we'll open up for any questions. If not, Jeff and I will be here for a little bit, but we'll be down on the networking booth in the expo. How long are we going to commit to?
Well, we've got a party tonight, right?
Okay, we don't want to keep you from Harry Potter, but we'll be there for an hour or so after the test. But thank you very much for coming.
Hello? Hello?